We are continuing with our series called Basic Training. This is a series of videos that I have developed that I think will be beneficial to my students and electronic engineering students in general. Um, Over the years, I have taught electronics for the last 15 years, and I have realized there are some gaps in our curriculum. And hopefully this basic training series will fill those gaps. The title of this session is called Circuit Diagram to Block Diagram. Many times in our curriculum or in our training, we start off with learning how to draw or learning how to read circuits. And initially, we start off with a circuit maybe like this. And we are asked by our teachers to analyze the circuit. I call this a loop circuit. You can clearly see that this represents a loop where energy leaves the positive terminal and returns back through the negative terminal through wires and components. We also may have experienced another circuit like this where we connect components in parallel. And through circuit analysis, we might be able to realize that we have two loops because there's more than one way for the current to move around the circuit. And again, we're asked to analyze the circuit, meaning we would like to calculate the different voltages and currents in the circuit. Then we move further into the next level where we were asked to analyze these same circuits, but this time we were asked to analyze the circuits maybe using a resistor and a capacitor with an AC energy source. An AC energy source is an energy source, an energy source which changes over time. So normally we represent this as a function of time. And we learned that we have an additional parameter called frequency, where we can alter the frequency of the changing signal. And that causes different behaviors. And we were able to analyze maybe a voltage drop across the capacitor and maybe a voltage drop across the resistor. And we learned that perhaps as the frequency increased, the voltage drop across one of the components perhaps did something like that. Perhaps the voltage drop across the capacitor begins to decrease as we increased. Believe it or not, that was our first introduction. Our first introduction into system analysis. Why? Because after we did this analysis, then we went to another subject called filters. And we said, okay, let's suppose we have an input And I remember this in my training where we drew the circuit like this, and then we extended some wires out here, and we call this V out. And we will be required to change this to what we call V in. So instead of just looking at this as an energy source, we do not consider this as an energy source. We start thinking of this as an input signal. So right before our eyes, without many of us knowing, we were beginning to move away from analysis like loops, and we begin to move more into system analysis. Unfortunately, however, the transition into loop analysis, into this format of analysis, was so, I don't know the right word, was so quick, subtle, so gentle, that our previous experience that we learned didn't seem to help us in this area. But that's what happened. We began to look at systems, magically coming up with something called V in and V out. Where did this idea come from? Unfortunately, this was not introduced properly, in my opinion. Now, the title of this subject is called Moving from Circuit Analysis to Block Diagrams. Instead of drawing the whole circuit, we could, once we get the relationship between the input and the output, we do not have to draw the whole circuit. We could just represent the whole entire circuit as a block. And we can say this side of the block would be the output, and this side of the block would be the input. And then we would come up with something called the transfer function, or the gain of this block, which basically tells you the relationship between the output and the input based on time, based on the input voltage, and based on frequency, whichever variable or parameter you want to focus on. Meaning, if we change the input, what happens to the output? How does the output change with the input over time? If we change the frequency, how does the output change with the input? So this is how block diagrams got started. So right under our noses, which basically means right before our eyes, we were gently being led from one type of circuit analysis to another type of circuit analysis. The unfortunate thing is that this was introduced within the same course. So the students was unable to synthesize what they have learned. In actuality, this kind of analysis is greatly different and understanding than this type of analysis. In this type of analysis, we focus on a component, and the purpose is to identify how to get energy into the component. In this type of analysis, there are no components to analyze. There's only the system block, the behavior of the block as it relates to some form of input, what type of output you get. That is a totally different idea than the energy load concept. So as electronic engineers, you must become skilled at learning how to change from a circuit into a block. That will depend on what you have identified to be the input points, the point where you apply a voltage, and the output points, the 2 points where you receive a voltage. This is the concept of having an input and an output. The final step, usually we do not consider including this part of the block. We only want to focus on the signal part, or basically where the energy goes in. And in this example, the energy comes in here and it goes out there. Now electrically, we know that the current goes here and some of it goes down to the negative, and while the other comes out at this point. But we usually do not add this part into the block. We simply focus on just where the energy is coming in and where the energy is going out. And then we draw the gain. So this becomes our block diagram. In the next video, I will take a complete circuit and show you how to transform that circuit into a block diagram.